direction, any slot you give, we will have there. Okay, so the evaluation part is clear, frozen, 15 for tutorial, 10 for quizzes. So let's continue what we are doing. Camera is rolling? You can, it's on already, okay. So we were doing hazard assessment. We defined hazard, okay, and hazard we defined as intensity of ground shaking, okay, and this can be represented first of all the ground motion record itself, so we can represent by ground motion record, which gives us the complete characteristics, known as well as unknown, okay. Then there are three important characteristics. Amplitude, frequency content, and duration. We discussed that earthquake record with time is a random time series, okay, which amplitude we should take. So one way of taking that is whatever is the peak value. So we can take PGA, which is nothing but the peak absolute value, absolute peak value. Direction is not important. It may be in plus direction, minus direction, because that is our chosen direction. So that peak value we take. But is it justifiable to take one peak? So there is a one peak for a small duration, which is very large. All other amplitudes are much smaller. So is the peak representative of damage potential? For example, there is one record which is having one peak of very high amplitude. Other peaks are smaller. On the other hand, there is another record which is having several peaks of similar amplitude but smaller than this. So which will have more damage potential? Second one may have larger potential. So just based on PGA or PGV or PGD, we can't decide that this particular earthquake is having more damage potential, means more intensity. So then people thought about what should be the other possibilities. So they considered sustained amplitude. What is sustained amplitude? A number of cycles or a number of pulses of amplitude larger than the given value. And these numbers are considered as 3 or 5. Okay. For example, we call third sustained cycle acceleration. What does that mean? That 3 cycles are having amplitude equal to this value or higher. Okay. Similarly, we can say fifth sustained cycle acceleration. That means this acceleration is sustained for at least 5 cycles. Okay. So that acceleration which is sustained for larger number of cycles, that is important. Okay. But again, this was also not found to be a very good indicator. These are available in literature but not used actually. So a better indicator of amplitude was effective peak ground acceleration, EPGA. EPGA is nothing but 1 upon 2.5 times average of acceleration, not acceleration, spectral acceleration, SA, in the period range 0.1 to 0.3 second. What does that mean? That you will plot the response spectrum, SA versus T, take 0.1 second ordinate, 0.3 second, get the average of these. This is SA average, 0.1 to 0.3 second, and divide this by 2.5. So this is EPGA. And this is 2.5 times EPGA. How this figure of 2.5 came? They did normalization of a large number of response spectra. Okay, so they considered response spectra of a number of earthquakes. Their PGAs will be different. So one earthquake, let us say, is having response spectrum here. Another earthquake is having response spectrum here. You can't compare these. How you can compare these? You divide those by this value. Okay, ZPA, zero period acceleration. So then this will become normalized. Then this value will be same for the starting point will become 1 if you divide it by EPGA, and let us say this as well as this, both will come here 1.0. This is SA divided by ZP or EPG. Then this was done for several earthquakes, and then an average shape was plotted. And when this average shape was plotted, this came out to be 2.5. So this is our idealized average shape. So what is given in our code is not response spectrum. what is given as SAYG in our code. Okay, it starts from 1. So that is not response spectrum. That is spectral shape or normalized response spectrum. So this normalized response spectrum, this is giving us a spectral shape. So what is given in our code as SAYG, actually it should be SAYZ. The correct nomenclature will be SAYZ. It is not actually SAYG. Okay? SAYG is nothing but spectral acceleration in units of G. Acceleration, there can be different units. So G is also one of the conventional units. SI unit is meter per second square, but conventional units can be Gel or G. Okay, so that is one conventional unit. So SAYG is wrong. It should be SAYZ. And when it will become SA? When you will multiply it by Z. So what is given in the code? This is SAYZ actually with T. And you have to multiply it by Z. Then it will become a spectral acceleration. Okay, so this value, when you multiply by Z, this will become Z. And this will be 2.5 Z. Currently, whenever you are using, we will discuss that, whenever you are using an attenuation relationship in terms of PGA, invariably it is EPGA. So you will find EPGA written as PGA. Okay, because PGA, if you are measuring from the ground motion, it will depend upon the instrument characteristics also. If there is a very sensitive instrument, you may get a higher peak. It is recording even smaller peaks. If you are recording at larger interval, okay, your recording frequency is smaller. That means delta T at which you are recording, that is more. Some of the peaks your instrument may miss. So it will depend upon the instrument also. That's why it is not a very reliable method of representing amplitude. Amplitude is better represented by EPGA. So in all these equations which we are going to discuss, and we will be following most of the things you can find in this book, Kramer. Geotechnical people might have already seen this. Actually, it is on geotechnical earthquake engineering, but initial chapters here are on hazard. So this book so far deals with the hazard in the best manner. So initial chapters you can read. Okay, and whatever I am discussing here, this is also, most portion is taken from here. Okay, so here we will see later that there are attenuation relationships, and this book uses term PGA or PHA, peak horizontal acceleration. That PHA is nothing but EPGA. This you have to keep in mind. It is not PGA taken from the ground motion, rather EPGA, and EPGA is obtained from response spectrum. Okay, so it is sort of effective measure. This is a better representative of the attenuation, of the amplitude or damage potential. I said better, but again not ideal. Better than PGA. Okay. So damage potential also depends on frequency content. Damage potential does not depend only on the amplitude. It depends on frequency content also. Yes.
So Z is an absolute number, while when we use sometimes SA by G, so the unit consistency will it remain or not?
So what is Z?
So Z is some absolute value will be taken as zone factor.
Fine. Any absolute value is representing something. So what is Z representing? It must be representing something, no? So what it is representing? So first of all, it is not an absolute number. Okay? It is in the units of G. So Z value of 0.36 in zone 5, what does that mean? It means that the effective peak ground acceleration in that zone is 0.36 G. Because it is in the units of the G, then it appears as the unitless. Okay, because acceleration is also meter per second square, G is also meter per second square, so that cancels out. So it looks like that it is an absolute number. It is not an absolute number. It is not just a number assigned to the zone. Okay, it is the value of EPGA in the units of G. Okay, so when you are calculating your base shear, design base shear, you consider Z by 2 into I by R into SA by G into W. Okay, so this will work only till W you have placed in kilonewton. Okay, if you have to calculate force, it is M into A. What are the units of A? Meter per second square. What are the units of M? Kg. Okay. Alternatively, you can write this as W into A by G. So here A by G, or A if you are putting in the units of G, then you have to multiply weight in kilonewton. So actually it should have been Z by 2 into I by R into SA by Z into W. This is the correct expression. But historically, somehow in the code it is printed as SA by G, and they are continuing with this. And people have this misconception that Z is some magical number. It's not a magical number, randomly given number. It is representing the expected EPGA in that zone. Okay? It has a physical significance. It is not just some randomly given number. It has come from seismic hazard analysis of the country. Okay? What you have to keep in mind is that its unit are G, and then you have to simply multiply it with the weight, not the mass. You have to multiply it with the weight because units are G. So actually it should have been SA by Z. Code is under revision. It is already in wide circulation. Which is our code for earthquake? IS 1893. What is the latest version? 2000? Draft version is 2000. But what is, what is the latest code version which is accepted? ऐसे बोल रहा है कि कुछ समझ में ना आए कि 2016 कि 2020 okay, it is 2016 which is currently in use, and 2023 or 24 depending on what number they give, because it was put in wide circulation in 23, but it will come in 24. Like 2016 also actually came in July 2017. Okay, so yes.
सर जो बेस ईयर है ये फिर जोन फैक्टर पे डिपेंड नहीं करता,
बेस ईयर जोन फैक्टर पर डिपेंड नहीं करता,
लाइक जेड जेड कैंसिल आउट हो जाएगा जोन फैक्टर पे डिपेंड.
ठीक है, कर देते हैं कैंसिल. ठीक, What is SA in zone 5? You need SA value. You can cancel out zone factor. But when you cancel out, you will need the value of SA. What is the value of SA in a particular zone? Suppose the period of the structure is 1 second. What is the value of SA?
So we get this value from responses.
From?
Responses.
Where is response spectrum? Have you seen response spectrum? You have seen code. That's what I want to, that confusion I want to remove from your mind, that what is given in the code is not response spectrum. It is a spectral shape. What is given as SA by G the code gives this as SA by G and then this value as 1 and this as 2.5 and this as 1 by T. Okay. It is not response spectrum. It is a spectral shape. And the code has not clearly written that. People think that this is the value of SA. It is not the value of SA. It is value of SA by Z. When you will multiply it by Z, then only it will become SA. So, it is equal to 1 upon 2 into I by R. What is given in the code is SA by Z. You need to multiply it by Z to make it SA. That Z is taken here. So code has not clearly mentioned that what is given as SA by G, what is that? Okay, and what is Z? That's why there is a lot of confusion. So I want you to be clear about that. You should not have this confusion. Z is effective peak ground acceleration. And SA by G, which is given in the Z, which is actually SA by Z, is a spectral shape. And when you multiply it by Z, then only it becomes a spectral acceleration, SA. Okay? So, a better representation of damage potential is response spectrum. Okay. Now with, yes, ask others. Others may also having this is a simple thing, but lot of confusion is there. So please do ask. Ask again and again. It's not that only you are not clear. I'm sure many here are not clear. So please ask.
Sir, can you overall the formula में ये SA by G, it is SA by Z.
SA by Z. Actually it is SA by Z. Code writes it's SA by G, and due to that there are a lot of confusion. Because you think that is SA by G, so that you multiply by G will give you SA, and Z is some magic number extra. So what is this extra number? Why we are multiplying it? So it causes confusion because SA by Z in the code wrongly has been written as SA by G. So actually it is SA by Z. Okay. So that's why to make it SA, you need to multiply it by. So it is not printing, it is conceptual mistake. It is not that typographical error. Committee has written something else and while printing no. Committee only wrote it. Historically somehow it is coming because the reason for that is, if you look at the history, I was going to talk about this. Let's talk about this first. Evolution of earthquake resistant design. So the first thing we learnt about earthquakes is that earthquake causes a horizontal force. it causes force in the horizontal direction. Okay, this was the first breakthrough about understanding of earthquake. Before that, earthquake was causing a lot of damage, but it was not clear why the damage it is causing. So it was because the earthquake is primarily, earthquake has all the three directions again, or rather six. Real earthquake ground motion has all the three translations and all the three rotations. In general, any particle have 6 degrees of freedom. Earthquake causes motion in all the 6 degrees of freedom. Okay, not one horizontal or two horizontal or horizontal and vertical. It has rotation also. And so far, courts are not talking about rotation because instruments to measure rotational motion were not available. Now there are instruments available with which we can measure the rotational component also. And people are measuring now rotational components. So actually there is 6 degrees of freedom. 6 motions are occurring. Now instruments were not there. People were observing only damage and they were feeling the shaking. So it took a lot of time to understand that earthquake actually is causing horizontal acceleration, and that acceleration is causing damage to our structures. Whereas in the vertical direction, we are always designing for an acceleration equal to g. 1g we are designing. In earthquake, we are designing, even in zone 5, our Z value is 0.36 g, much less than 1g. So in horizontal direction, the structures can take much less load. Every structure is inherently weak in horizontal direction as compared to vertical direction. Why? Why in horizontal direction a structure is weaker as compared to vertical direction? Vertical direction, every structure can take 1g. Horizontal direction, it can't take even 0.36 g. Why?
Load is not persistent.
Bending of what?
Sir, because we built that way, because there is no horizontal acceleration, only acceleration due to gravity.
No, I couldn't get. Vertical acceleration due to gravity is always there. Think it like this. I have a structure building, I tilt it at 90 degrees. So what is happening? This 1g is acting downward. Without any calculation, from your gut feeling, do you think a structure will survive this? Why not?
What is the we have designed for vertical forces, not horizontal?
Because the ladder beams will take it come.
Whatever you have designed, suppose I have not designed, I have just constructed. Forget about design. I have just constructed. And that is standing in vertical direction, I tilt it at 90 degrees. Will it survive? Why not?
Sir, because suppose we go to primitive era, we are building in that way ki, brick will fall or something, stone will fall downwards, not it will go horizontal.
Now that will happen under gravity.
So why one will build that way ki, structure is going swaying horizontally?
Sorry, why one?
Why the people will build that way ki, structure is
They have to build. Earthquake, we are building now like that because now we have understood. What I mean to say, forget about how you are building, how you are designing. There is a structure. Okay, you tilt it 90 degrees. Will it survive?
Means there is no support, someone to assist that object.
No, it will act like a cantilever. There is support.
So when we bend it, the bending will now be about weaker axis instead of the stronger axis. So it will automatically.
Weaker axis. Which one is the weaker axis? Let us say the plan is a square. So which one is the weaker axis?
When we are designing it such that the bending is taken like we are designing it for the out of the plane bending. Like if bending is in this manner, like it should be able to take. When we twist it.
Bending in this direction means what? What do you mean by bending in this direction? Let me give you another quiz. I give you any stick and ask you to break it. How you are going to break? Will you try breaking it like this? You will always try like this. Have you done any calculation that it is weaker in bending and stronger in axial action? Still you will do it like this. Why? Because from day-to-day experience, your brain already knows without studying. Even an illiterate person will do it like this. So without studying, without any mechanics, your brain from your day-to-day life has understood that everything is weaker in bending as compared to axial action. So this your brain knows. So you will always try like this. So this is inherent properties of any component or structure, that it is weaker in bending than in axial action. Okay, why? Why it is weaker in bending than in axial action? Can you prove it with mechanics? Which principle of mechanics comes into picture? Suppose I give you a stick which you can't break like this. What you will do? Which you can't break like this. A long stick I give you. Okay, you have to break it. How you will break it?
So by impact.
By?
Impact.
Okay, that is one thing. Other than impact, suppose it's not breaking with impact, it is stronger than that. What will you do? कभी लकड़ी तोड़ी पेड़ से? कैसे तोड़ते हैं? No, suppose there is a stick, you have already branch, you have broken. You want to make, so you put it in the middle of this and push it here. What you are doing with this? You are using the principle of lever. Okay, so this is principle of lever. Archimedes gave that, and Archimedes said that if I get a lever in the space, I can shift the planets. It is such a strong principle that if only thing is that you need a fulcrum. So if you can get a fulcrum, with the help of lever, you can even shift the planets. Okay, so this is the concept of lever. We are using it to break or to move. Earthquake is also doing that. In vertical direction, okay, your beams are in bending under vertical force. Your columns or walls are in bending. Okay. Sorry, your beams are in bending, columns and walls are in axial action. But under horizontal force, your columns are in bending. So those columns are inherently weak in bending. So columns will fail under lateral load. Okay, so horizontal force, because it is causing lever action, okay, and our structures as well as components are weaker in bending action, horizontal action is more damaging. Horizontal force is more damaging. So horizontal force causes more damage, okay, as compared to vertical load. And that's what you understand, that in vertical direction, every structure, whichever is there, is resisting 1G throughout its life. 1G in vertical direction is always acting. But in the horizontal direction, actually you will see that the force is much less, 5% only. So 5% of G comes in the horizontal direction in case of a moderate or tall building, and under 5% of G it fails, because the lever arm is very high. So due to that, it fails in the horizontal direction. So first thing we understood about earthquake is that it is subjecting our structures, or it is testing our structures in their weaker action, which is lateral action. Now once we understood this, what will be the remedy? What will be the next step? Let us design it in the horizontal direction also. Question was, how much force we should apply? For how much force we should design? No instrumentation was done. No PGA, EPGA response spectrum was known at that time. So what should we do? Some wise people, somehow, they have this intuition, okay, which cannot be explained because science was not available. So from their intuition, from their thinking, they suggested, let us design for 10% of the weight in horizontal direction. Because nothing was known about earthquake. Then some people suggested that no, earthquakes are more damaging in some part, those are less damaging in other parts. So let's not design all the structures for 10%, let us design for different levels. So that was the first level of our code, which came in 1962. First IS 1893 came in 1962. And there some percentages of weight were given for design in different parts of the country, that was seismic coefficient. So this they call seismic coefficient. And it is only a percentage. This is unitless. It is just fraction of the weight which we need to consider in the horizontal direction. Okay. From here the journey started. Just the wise people sitting in the code committee, a group decided that in different parts of the country, let us design for 10%, 8%, 5%, 2%. So they divided the country into 7 zones. Okay, zone 0 to zone 6. And in different zones, they suggested different fractions of the weight, which they called as seismic coefficient, that let's use these as the coefficient of weight, which we should consider in the horizontal direction. That is a starting point of our journey. Throughout the world this happened, because nobody has done measurement till then. Measurements started in 1950s, 60s. So in 1960 when our code came, very little understanding about the nature of earthquake was there. So people were in China, US, Japan, and almost at the same time in India, they started studying the earthquakes. Then instruments were put, different parts of the world, earthquakes were recorded, and it was seen that very interestingly, those earthquake ground motion is much larger. The PGA is not 0.1 G, it is much larger than 0.1 G. So then there was curiosity that we have designed maximum up to 10% of G, 0.1 G we have designed, but our structures have survived much larger PGA. How this is happening? So then they found two things responsible for that. One is the dynamic behavior, means frequency, detuning, and inelastic energy dissipation. So with this, they understood that actually the structure can survive much larger earthquake than what we are designing for. And earthquake records were available. Newmark gave the concept of response spectrum. So the concept of response spectrum was there. So the next revision of the code, when it came, they used a reduced response spectrum. So they gave a reduced response spectrum, and this response spectrum was also arbitrarily reduced. At that time, it was not possible to estimate what response spectrum we are expecting at a site. Okay, so some reduced response spectra were given. So these were reduced. So SA was, again, concept of response spectrum came, but this value was decided by the code committee. This was arbitrary. This was not based on any analytical or measurement study, just based on their judgment, they decided. Because we cannot wait to construct our structures till we understand everything. This continued till 2001 revision of the code. Okay, just the previous version of the current version. So the change there was that Hazard in 2001, IS 1893, 2001, realistic estimate of hazard. was made. Okay, and then the realistic response spectrum was given. (2002) Okay. 2001 was the earthquake, yes. 2002 it came, yes. 2001 there was Bhuj earthquake, and immediately after that there was revision of the code. So this was 2002. Okay. So there they made a realistic estimation of hazard. That means a realistic response spectrum. This realistic response spectrum was based on deterministic approach. Deterministic seismic hazard assessment, DSHA, in short we call. Okay, but the continuity was coming from here, where we were talking about a fraction. So that's how this misconception of the fraction, this DSHA, this was relatively new thing at that time. Not everybody in the code committee was understanding this. So most of the code committee was having this understanding, that fraction. So that's why most of the people still think Z is a fraction. Because initially it was given as a fraction. And it was not well documented also. In code something was given, and somebody in code committee, you of course how you people will see the meetings of the code committee. So in the code committee, when the meetings are occurring, different people with their own background, and they understand things differently. And then code is like a compromise document which is acceptable to everybody. Okay. So somehow there this SAYG started, because people were in a habit of thinking it in terms of fraction. But actually it came from deterministic seismic hazard assessment. Professor Basu from our department, and there was one professor in nuclear power, one scientist. They together did this exercise, and they came out with the value of EPGA in different zones, different parts of the country. But that study was also not complete. So at many places they have to again use their judgment. So that's why the zones which were decided, if you look at the seismic zone 4, in Delhi it goes like this. So simply because Delhi is an important city, they wanted to keep it in higher zone. So it was not based on exactly analysis. Judgment was also used because analysis results were not sufficient. So that's how this 2002 code, which is the hazard is still valid. The same hazard we are using. Now, in this revision, which I am telling you 2023 or 2024, whatever the name will be given, there the probabilistic seismic hazard assessment has been done for the country. So that is the latest methodology. Now this confusion is not there. Now it is clear. Okay, I will give you an overview of the new code also. Okay, the presentation which is here, that also I can share with you. So there I have compared the new code and the old code, the relationship between DSHA and PSHA. What we have obtained from DSHA, earlier code, what we are having now from PSHA, how the two correlate. And one thing I can tell you, that using probabilistic seismic hazard assessment, the value of earthquake forces has increased. Okay. Actually, it is not because of the deterministic or probabilistic. You have to think earthquake resistant design is like an insurance. Earthquake is a rare event. Against that event, you are insuring your structures. How? By paying premium in the form of designing your structures for lateral forces. Higher lateral forces means the cost is more. Now, how much insurance you will take? Somebody will take insurance of 20 lakhs, somebody will take insurance of 1 crore, somebody will take insurance of 10 crores. How it will be decided? This will be decided based upon the economy condition of that person. More affluent people will take larger insurance. So when in 1962 they were starting, the country was quite poor. So at that time they thought of reducing, keeping the forces low. Okay, now the situation has changed. Our infrastructure has also become very costly. At that time the infrastructure was not that large infrastructure was not there. Now we have huge infrastructure. Only nuclear power plants, those were designed for higher forces. Other structures were designed for lower forces. Now we understand that our total cost of bridges, total cost of buildings is also huge. So that same philosophy cannot go. Now we are becoming more and more realistic. And most probably this is realistic now. We will not increase beyond this. So slowly, as the country has become more and more affluent, the earthquake forces have also increased. So if you take from 1962 to 2023, forces are continuously increasing. Okay, but not suddenly. Okay, there has to be a continuity. So the code you have to see in continuity with from where it started. It started from a fraction. And that confusion is going on. Now it will be clear. In 2023 it will be clear. But to be clear about 2023 code, you should understand the current code, which is currently applicable. Okay, so that's why I am discussing this. We will stop here and